All right, so we are on worksheet A47. If you look at it, it is still asking you to factor out the greatest common factor, or in this direction, factor the common factor out of each expression. So that means we're factoring out the GCF. So there's a big difference between factoring out the GCF and just finding the GCF. So if I asked you for just the GCF, what would it be in this one? The GCF is just 2x to the third. But that's not what they're asking. They're asking you to show you factor out. So we're doing the reverse distribution. So I'm going to put my 2x to the third out here, and then I'm going to show you what's left. Now, some of you are good with just, hey, I multiply by x, I get this back. I multiply by positive 1, I get it back. But for some people, and I think for me too sometimes when there's a lot going on, it's better to show I'm divided by 2x to the third, because then I see each piece. So this is what I'm dividing by. I have to show it here. But when I divide this out, the 2's and the x's cancel, but 1x. The 2's and the x's completely cancel, and something divided by itself is 1. So this is my final answer. Whether you get to it by looking at each piece or reversing distribution, as long as you're getting it correct, that's good. I think this is really helpful when you get into multiple variables or bigger numbers.
Can you put a 1 before the x?
You can have a 1 in front of the x. That would not be wrong. Okay, give me another one to do on the front.
Number 4.
Number 4?
Number 7.
All right. All right, we'll do 4 and we'll do 7. If you look at number 4, what number am I focusing on to try to find the GCF?
The smallest number, which is negative
4 and it's 4.
So I'm looking at the 45. Now,
Wait, I thought we were doing 7.
they jumped to 4, and then we're going to do 7. So 45 actually goes into 45 and 90. Does 45 go into 72 evenly? Is it a factor? No. Okay, so what's my next option? What else goes into 45? 4 doesn't go into 45. Oh, 9. Yes, yes. Okay, before I jump to 9, though, I probably would have thought about 15, because 15 goes into 45 and 90, but it also doesn't do 72. So I like the 9. Can I take out an n?
No.
No, I cannot take out an n. So just a 9. Again, if it helps you, show each piece divided by 9. This way it helps me with my signs too. 72 divided by 9? 8 into the third. Negative 45 divided by 9.
Negative 5.
Negative 5 with an n. And then 90 divided by 9. Positive 10. My problem is some of us are doing things too fast. We're missing signs. There were no variables here, but variables were a big problem. How do I know that I factored it completely?
If each, like, math or number, whatever you want to say, has
Term. If each term.
has a different, like,
They don't have a GCF again, right? So 5 and 10 have a GCF, but can I divide that by 8? No. Or 8 by 5? So 8 and 10 have a GCF of 2, but does 5 have it? So that's how I know I got the best answer. All right, look at number 7. It looks a little overwhelming, but there's only 1, 2, 3, 4 terms there. Do you see them? With those 4 terms, let's just talk about the number. What number am I focusing on to not be overwhelmed?
4.
Focusing on my 4. Does 4 divide into everything evenly? 4 is a factor of each number. I can't go higher. Now let's look at our variables. So everything's divided by 4. Hold on, I'm going to catch this up. Okay, y, or everyone has a y. How many y's can I take out?
2.
Do you guys agree on that? So the smallest power, can I take an x out of everything? No, because this one does not have an x. Okay? All right, so what am I doing? Y to the seconds coming off of each of these. When you are dividing variables, you're really subtracting or canceling the powers. All right, so what's left? 1, that's gone, right? There's 1y and x to the 8th there. Do we agree with this? If it helps you, put the 1 there. 28 divided by 4? 7. The y's cancel completely, but you're left with x3. All right, 8 divided by 4, positive 2. Y's cancel, x to the second. And then 12 divided by 4 is?
3.
Just 3, because the y's fully cancel. All right, let's flip it over and find 1 or 2 on the back. Your pick. Anything other than 20?
13.
All right, we'll do 13 and 20. Woo, 13's a little bit much, huh? Okay, now in 13, notice the leading coefficient here. The first term has a negative. You don't have to do it, but we're going to practice factoring out a negative. I'm looking at these 35s, and I know that's not my factor. What else goes into 35? 7. Does 7 work for everything? Okay. I'm going to do a negative 7, but you could do regular 7. What about p's? Do they all have a p? P2, P2, and a p to the first. So how many p's can I get rid of? Just one? All right. Q third, Q squared, Q to the first. How many Q's? Just one Q? Because so that's the one that we're looking for, the smallest one. All right, then I see M. M squared, M squared. Okay, so they don't all have a common M. So this is my GCF. It always has to be shown. What's left? If I divide out by a negative, all my signs flip. So what's negative 49 divided by negative 7? 7. Knock out one of the P's, knock out one of the Q's, and keep your M squared. So 7P, Q squared, M squared. I'm running out of room already. All right, 35 divided by negative 7. But it's going to be a negative 5 if I'm changing the signs, right? Knock out a P, knock out a Q, so I'm left with 1P, 1Q, and M squared. Negative divided by negative. Positive. So the same thing I've been trying to tell you guys. Look at your signs, look at your numbers, and then each variable. The P's and Q's completely cancel, so it's just positive 5. All right, I'm going to double check. I don't have any extra variables. 7, I can't take anything else out, so I'm good. All right, 20 was the next one, right?
Yeah.
Oh, I'm going to say this again. You do not have to take out a negative number, but if the leading coefficient, only if it's negative, that's when I take it out. So I would not factor out a negative here, but I would on these. This one's not in standard form, but that's okay. All right, 20. What do we see? Number-wise, what am I focused on? The 10. Can I take 10 out of 40? So you guys tell me to go to 5?
Yeah.
Okay. What about my variables? Take a minute, write down what you think the GCF is. Yes. Yes. Are you good on this? Okay. Can I take any X's out? How many? Just one X? All right. How about Y's? Just.
I don't understand that. Can you explain that? What determines how many X's or whatever you can take out?
The short version of it, the lowest power determines if I can take it out. So like.
So whatever the lowest power is, that's how many X's.
Yeah. I can take 3 X's out of here, but can I pull 3 from here?
Gotcha.
So it's basically, that's why I said it's an oxymoron. It's the greatest common factor, but we look at the smallest number because I can't take anything bigger out in the smallest power. Now, in an example like this, these all have Z's, but this one doesn't have a Z, so that's why I can't take any out. All right, so we're agreeing on 1X. What about the Y's? So here's 5, here's 1, so I can only take out 1. That was lovely.
Sorry, I drifted my phone.
That's awesome.
It was probably your antenna, like pulling it to the side.
Yeah, right.
All right,
I
so
almost went to someone's yard though.
I'm sure they would not have been happy. All right, so I'm dividing by 5. The X's completely cancel. I lose a Y, so I have Y the fourth, Z to the second. A positive 2 keeps 2 of the X's, knock out the Y, and Z to the fourth. This is going to end up being a negative 2. What about the X and Y on this one? They're gone, aren't they? So negative 2Z, and this is going to be a negative 9. X is gone, and I get 1Y. And there it is. So I say it's worth the extra effort to double check it. 10, 2, 2. Okay, 9 throws it off. Otherwise, I could divide it again by 2. X does not show up everywhere. Y doesn't show up everywhere. So as long as there's nothing left in common, we got it. All right, anything else? All right, so go ahead and finish these.